Hello everyone, welcome back to my YouTube channel. In today's video, we are going to solve LeetCode question number 367, which is called a valid perfect square. In previous solution, we saw how to use binary set, but in this video, I will show you another way efficient mathematical approach using Newton's method. Let's get started. The problem says we given a positive integer number return true if number is a perfect square or false otherwise. Perfect square is an integer that is the square of an integer. In another word, it is the product of some integer with itself. You must not use any inbuilt function like sqrt. Let's take an example. We input number is equal to 60. So we saw that output is true because s- we return true because 4 into 4 is equal to 16, and 16 is an integer number. Let's take a second example. We input number 40. So we saw that output is false because 3.742 into 3.742 is equal to 14, and 3.742 is not an integer number. So in this question, our approach is very simple, and in this question we use Newton's method. Idea is based on the square root approximation formula. We started initial guess x is equal to number. After that, then we update x using this formula, like x is equal to x plus number by x whole square divided by 2. We keep repeating this until x into x less than equal to number. Finally, if x into x is equal to number, then number is a perfect square. This method is much faster than linear search and often perform better than uh, binary search in practice. So let's get started to the code. We first declare a variable called long x is equal to number. After that, we declare a while loop x into x greater than number. So we use formula, Newton formula, x plus num sorry divide by 2 x plus divide by x or divide by 2, whole divide by 2. After that, we return that x into x is equal to the number, so it, it is a perfect. So we run the code. After that, we saw that every test cases is passed and our code is successfully run. So this is the Newton's formula. We start with x is equal to number, while x into x greater than number. We keep updating x using Newton's formula to gradually reduce x until it gets close to the square root of num. Finally, x into x is equal to num, then num is a perfect square, otherwise it's not. The time complexity approximately is like order of log n because the value of x is decreasing very quickly. The space complexity of uh, this code is order of 1. And that's it for the video. Thank you for watching this video.